So I'm going to quickly run through what I think of as manipulating interaction equations or manipulating interactions. And what I'm going to try and do is show you how to get more out of what you know. Therefore, you actually have to know less. So I'm going to start off with a simple interaction that you should all be very familiar with. So I've got a proton decaying into a beta minus plus an anti-electron neutrino. And that is our standard beta plus decay. And you've been learning about that for some time at GCSE. Beta plus decay, beta minus decay. Now you've been learning about that for some time at GCSE, and at A level you'll have added on the anti-electron neutrino. Now, what people aren't necessarily aware of is the fact that we can treat these as almost mathematical style equations. So we can actually manipulate them. So the first thing I'm going to do is take off an anti-electron neutrino from both sides. So now I've got a neutron minus anti-electron neutrino goes to a proton plus a beta particle, or beta minus particle. Now in this case my conservation laws must still hold because I've changed both sides equally. So that then is a valid interaction. But the second thing I can do is I can say, well, a minus and anti, the same as a minus and minus is a plus. A minus and anti is actually a plus. So I've actually got a neutron plus an electron neutrino is going to give me a proton plus a beta particle. Okay. Now I'm going to swap this around ever so slightly. And so I'm going to move this as our start point, because these things could be two-way anyway, to be brutally honest. So I'm going to write a proton, and rather than a beta particle, we know a beta minus particle, we know that's actually an electron. And that's going to give me a neutron plus an electron neutrino. So what I've got here then is just manipulating, following all of the standard laws, just manipulating the equations, therefore still following all of the standard conservation laws. I've got a proton plus an electron gives me a neutron plus an electron neutrino. Hang on a minute, that's something we have to know about. That is called electron capture. When maybe an electron in the inner lowest energy shell or energy level gets grabbed by the nucleus and actually converted then from a proton into a neutron in the nucleus. And in this case, you can see it's going to be emitting an electron neutrino. So from my beta minus decay and a little bit of manipulation, I now understand the interaction for electron capture. Now, I'm going to have another go and play around with this a little bit further. And what I'm going to say now is go, well, okay. What I'm going to do is take off my electron. And what I'm going to do then, or I'm going to go from here and have it back as a beta minus particle. It's the same thing in terms of our conservation laws. Beta minus is just a high energy electron, and the energy element isn't considered in this interaction anyway. So I've got that. And what I'm going to do is I'm going to take off the beta minus from this side. So what I've got here then is I'm going to take a proton, and that proton then is going to be changing into a neutron plus an electron neutrino, and I've had to minus a beta minus particle out of both sides. So, okay. So, what's actually happening now is I've got a minus minus again. So I've got a minus of a beta particle. Now a minus means it's the anti-particle version of it. Sorry, I've put an anti-electron neutrino there. So I then end up for a proton is actually going to a neutron plus an electron neutrino plus a beta positive in terms of the setup. Now, what I can do then is, again, take this to the other side. So now I've got a proton minus an electron neutrino goes to a neutron plus a beta plus. But I've got a minus sign here. So that's the same as writing a proton plus an anti-electron neutrino goes to a neutron plus beta positive. So in this case, what I've actually worked out is the proton, antineutrino, that's an anti-electron neutrino interaction. Now, hopefully you can see from this the fact that all I had to know was beta decay, but I can now actually work out through simple manipulation electron capture and the interaction, proton antineutrino interaction, and indeed I could keep going from there in terms of combining these things differently. Hopefully that makes sense. Hopefully you can see how that means you need to remember less for your exam by manipulating those interactions that you know. Thank you very much.